This is another example of the find the turnaround time using the round robin algorithm. So the following processes are being scheduled using a primitive round robin scheduling algorithm. Each process is assigned a numerical priority with a higher number indicating a higher relative priority. So these are the priority given 40, 30, 30 and so on. Okay. In addition to the processes listed below, the system also has an idle task, okay, which consumes no CPU resource and is identified as idle. So if there is no any process is running in between, okay, so that time the it will consider like idle time for the CPU. This task has priority 0 and is scheduled whenever the system has no other available process to run. Okay, the length of the time quantum is 10 unit. So the quantum is 10, right? If a process is preempted by a higher priority process, the preempted process is placed at the end of the queue, right? So the process will place to the end of the queue. If the process, the high priority process enter into the system, then high priority process will execute first, right? Okay. Now these are the threads, yani processes P1, P2, P3, P4, P5 and P6, right? These are the priority, burst time is given and the arrival time is given. Okay. Now show the scheduling order of the process using a Gantt chart. So prepare a Gantt chart and show the scheduling order of the processes, right? Now I will prepare the Gantt chart here. So which process will execute first? Yes. Okay. Now P1 will execute from 0 to 10. Yes. So P1 will execute from 0 to 10. Right? Okay. At 10, no any other process enter into the system. Okay. So the arrival time is 0, then 25. So up to 25 there were no any other process. So just P1. So P1 also has high priority. So P1 just alone in the system. So the burst time is 20 for P1. So 10 is already finished. So again P1 will execute, right? Up to 20. Clear? Clear? So P1 execute completely and it will go out from the system, right? There is no any other process. Clear? Right? Now the another process enter into the system at 25. So between 20 and 25 no any other process was there. Okay, from 20 to 25. So this time the CPU is going to idle, right? Because this time there were no any other process in the system, right? Clear? Okay, so this is the idle time. Now at 25, process P2 enter into the system. So P2 will start to execute, okay, from 25 to 35. Okay, clear? Right? Because the quantum is 10. Okay, so 15 is remaining, right? Now P3 enter into the system at 30. Clear? So at 30, at 35 there is two process in the system, P2 and P3. Okay, both has same priority, 30 and 30. Clear? So which process will execute now? Yes. Hmm? Yes. So if the process has the same priority, then the process there is first come first served algorithm will apply it. Okay, yani first process will execute first, right? So now which process will execute? P2. Okay, so P2 will execute up to 45, right? Okay, so 5 is remaining. 5 is remaining for P2. Now P3 will start to execute. P3 will execute up to 55. Then, sorry, P2 will execute again, right? And P2 will execute up to 50, right? Okay, and finish. P2 finish from the system, right? Now P3 will start to execute and P3 will execute up to 60, okay, and P3 will have 15 remaining. Clear? At 60, another process enter into the system, and this process has high priority than P3. Okay, so P4 will start to execute now. Okay, so P4 60 to 70. Clear? Okay, so P4 will have remaining 5, right? So there is no any other process, just P3 and P4. So P4 will execute again up to 75. Okay, 75, and P4 will exit from the system, right? Okay, so there is just P3 in the system right now. So P3 will execute again. P3 will execute up to 85, okay, and it's still 5 remaining. So P3 will execute again up to 90, okay, and P3 exit from the system, right? So there is no any other process in the system up to 100. So 90 to 100, the CPU will go again to the idle state. There is no any other process, right? Okay, clear? Right. At 100, the another process P5 entered into the system. So P5 will execute now. So P5 100 to 110, okay, and P5 exit from the system, right? Now P6 will start to execute. P6, so P6 enter into the system at 105 and it has just 10, so 120, right? So all the process has finished their execution. What? Round robin algorithm, yes. Okay, so the first question is show the scheduling order of the process using a Gantt chart. So this is the Gantt chart and this is the scheduling order: P1, P1, P2, 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 P3, P4, P4, P3, P3, P5, P6. Okay, so this is the scheduling order, right? Okay, so this is the answer of the A question. Now what is the turnaround time for each process? Now you will find the turnaround time. Okay, so turnaround time, do you know what is turnaround time? So turnaround time is the time taken by the process from entry to exit. Okay, the process enter into the system and exit from the system. The time duration from the time during from the entry to the exit. Okay, clear? So turnaround time of process P1. What is the turnaround time of process P1? So process P1 enter into the system at 0, okay, and exit from the system at 20, right? So what is the turnaround time? 20, 0 to 20, right? So the turnaround time of process P1 is 20. Clear? Right? What? Not, no, arrival minus arrival, but arrival was 0. Okay, now P2. So what is the turnaround time of P2? P2 enter into the system at 25, okay, and exit from the system at 50, right? So 50 minus 25 is 25. So P2 turnaround time is 25. What about P3? So P3 enter into the system at 30. and exit from the system at 90. Okay, so 90 minus 30 will be 60. What about P4? So P4 enter into the system at 60 and exit from the system at 75. So 15. Okay. Then P5 enter into the system at 100 and exit from the system 110. So 10. Okay. P6 enter into the system at 105 and exit 120. So 15. Okay. Right. So this is the turnaround time for each process. Right? So in the question they ask the turnaround time for each process. Okay, now if you want to find the average turnaround time, so you have to add all together and divide by 6. 15. Okay, P6 enter into the system at 105, right, and exit from the system 120. Okay, so 120 minus 105. Yeah. No. From entry to exit. Okay. So P6 enter into the system at 105 and exit from the system at 120. Right. So P6 wait 5 millisecond, and after that start to execute. Right. Okay. Right. Any other question? P. This one P6. This one or C or D? No, I will explain. Okay. Now the C is what is waiting time for each process. So C answer is waiting time for each process. Waiting time of P1. First P1. What is the waiting time of P1? See, P1 enter into the system at 0. Okay, and start the execution at 0. So the P1 waiting time is nothing, 0, right? So P1 waiting time is 0. What about P2? So P2 enter into the system at 25 and start the execution at 25. Okay, so there is no any waiting time for P2. So P2 waiting time is 0. What about P3? So P3 enter into the system at 30 and start the execution at 50. Okay. So now P3 will have how much waiting time? 20, right? So 20 here, and also P3 doesn't finish yet. Okay. So P3 will have another waiting time from 60 to 75. Okay, right? This time P3 was waiting. Clear? So from 60 to 75 is 15. So plus 15. So total waiting time for P3 is 35. P2? Where? P2 25 to 50. No, P2 has finished their execution here. Okay, so P2 doesn't execute again. Now P4. Yes. Which one? P3, right? So P3 enter into the system at 30, right? Yes. P3 enter into the arrive at 30. Clear? And P3 start the execution at 50. P3 start the execution at 50, right? Okay. Clear? So P3 start the execution at 50 here. Okay. And P3 enter into the system at 30. So 50 minus 30 is 20. 20 here, right? 20 plus 15, because P3 is waiting from 60 to 75. Okay, so 15 here, right? So total is 35. Now P4 enter into the system at 60, right? P4 enter into the system at 60. Clear? Clear? And start the execution at 60, right? So there is no waiting time for P4. So P4 waiting time is 0. And P4 finish the execution here only, okay? So, right? P3, P3, see again, P3, P3, see again, P3, the arrival time of P3 is 30, right? And the execution time of P3 is 50, right? So 50 minus 30 is 20. 20 is the waiting time. Clear? Now P3 doesn't finish their execution, so P3 wait from 60 to 75 because P4 enter into the system this time. Okay, so this is also the waiting time of P3, right? 75 minus 60 years. Not 85, 75. 75 minus 60. Yes. Okay. It's 15, right? So 15 and 20 is 35. Clear? Yes. Right? Okay. Now go to the P5. So what is the waiting time of P5? Yes. So P5 enter into the system at 100 and P5 start the execution at 100, right? So there is no waiting time for P5. What about P6? P6 enter into the system at 105 and start the execution at 110. So 5, right? So this is the waiting time for each process. Clear? Okay. So if I ask average waiting time, so you will add all the waiting time together and divide by 6. So it will be average waiting time. Okay. The another is, what is CPU utilization rate? Okay. So D question is CPU utilization rate. What is CPU utilization rate? Okay. See here. CPU utilization rate. So CPU start from 0 to 120. Okay. So how much time CPU works? It was free from 20 to 25, 5 time here, and 90 to 100, 10 times here. So 15 times was free in between. Okay. So 120 minus 15. So CPU utilization rate is equal to how much time it works? 105. Okay. So 105 divided by total time 120 and multiply by 100. Okay. So this is the formula to calculate the CPU utilization rate. Okay. So 105 multiply 100 and divided by 120. So it will be 87.5%. Okay. So this is the CPU utilization rate. Okay. So in this whole the scenario, CPU was utilized 87.5%. See, how much time CPU run? Okay, so CPU was run during whole the process 105 times. Okay, the total time was taken 120. Okay, so 105 divided by 120 and multiply by 100. So you will get 87.5%. So this is called CPU utilization rate. Okay. So I'm adding one more question in this whole the process. E question. What is the response time? response time for each process. For each process. What is the response time for each process? Clear? So the response time for each process P1. Okay. So what is the response time of P1? So see, P1 enter into the system at 0 and start the execution at 0. So there is no time. Okay. So response time for P1 is 0. Right. What about P2? P2 enter into the system at 25 and start the execution immediately at 25. So the response time was 0. Okay. No, it's different. Okay. So P3. So what about P3? So P3 enter into the system at 30 and start the execution at 50. Right. So 20 is the response time. Okay. P4. So what is the response time of P4? P4 entered into the system at 60 and start the execution at 60. Okay. So there is no time. P4 will be 0. Right. What about P5? So what is the response time of P5? So P5 entered into the system at 100 and start the execution at 100. So there is response time of P5 is 0. What about P6? P6 entered into the system 105 and start the execution at 110. So the response time is 5. Okay. So these are the response time of P1, P2, P3, P4, P5, P6. Response time is the time taken by a process from entry to start the execution. Okay, from entry to start the execution. Right? Clear? And waiting time, for example, P3 has this 15. Okay, 20 plus 15, right? So this 15 because P3 was not completely executed. Okay, but here no, here just from start to from entry to execution starting. Okay, this time from entry to start the execution. Clear? Huh? Okay. Okay. If you understand all the things, if you have any question, you can discuss now. Yeah.